continue the previous day's notes, or you can start a new one, but you need graph paper out. Tonight, 332, 107 to 111. Any issues with the lesson yesterday or the homework from yesterday? I'd love to take those questions to start. Any questions? Yeah, Simon. Yeah. Well, I told you guys you were essentially working independently. Question? Hey guys, I don't know why we have the side conversations, but I'd love for us to have a group conversation and help everybody. If you're trying to help one of your classmates, try to help them all. We can be efficient with this. In the lesson or the homework? So, do you remember which one? So you think it's tonight's homework? So, I can look it up. So, this pushes your work with order of operations, right? So order of operations, if we remind ourselves, is that PEMDAS, right? Parentheses, exponents, multiply, divide, add, subtract. So if we can solve inside of parentheses, we always have to do that first. So this set of parentheses doesn't mean do anything. That just is there for the negative. It doesn't even have to be there. Actually, with the division, it's appropriate to have it there. But like we don't have to put negative numbers in their own parentheses. So I want to do this, but I also want to do this. And since I have two different things to do inside parentheses, just work it left to right. So the first thing we do is 4 minus negative 3. Well, what would 4 minus a negative 3 turn into, Connor? 7. Turns into a 7. Then 5 divided by negative 5. Now I can rewrite that as 5 over negative 5. If I have one negative involved, will my answer be negative or positive? Negative, right? I cannot pair up. So, negative. What's a number divided by itself? 1. 7 plus a negative 1? 6. So it's all just remembering the process. And that's why we're not trying to have you guys like memorize different things. We want you to be comfortable with the process behind it. So does that make sense for how to get that? So up here we would do this first before we multiply with the negative 5 3/5. Other questions from this week? Yes.
We had this problem yesterday. It was with Ramona or something.
Was it in the lesson?
Yeah. We could not figure out what she was doing.
Ramona. Where are you, Ramona? Ah! Okay. Let's get real deep for a minute. I don't like getting deep. I'm trying to think the best way to show this. Ah. All right. What do you mean order by color? I didn't know there was an order of colors. Okay, we have 1 and 3/8, right? 1 and 3/8. Now, he wants to break his 1 and 3/8 up into groups of 3/4, right? Like 3/4 groups. So I know that there's more than a 3/4 group in here, right? Because it's 1. It's more than a 3/4. And there's less than a 3/4 here, because this is 3/8. Right? So this gets real weird. When I go to, and the problem is I don't have enough blocks to really show this. So I can take out 3/4 and make one group just with my nice purple blocks. right? What I can also do then is take out fourths by using eighths. Like every 2/8 is a fourth, right? So that's 1/4. Here's 2/4, and then I'm missing an eighth to make another 3/4 group. But if I put these on top of here, oh snap, I would need one more eighth stacked on top of here, and then would they line up? No. Shoot. So the problem is, if I group into this as a 3/4, what I have left over right here is not another 3/4 group. If it was another 3/4 group, my answer would be 2. Right? I got 2 groups of 3/4. But we can't now. So instead, we say, okay, well, this is 1, 2, 3, 4, 5/8 left over. And 5/8 compared to a group of 3/4 is actually, how'd she get 3/8? That, do you think Ramona's right, or do we think she's wrong? How many 8s make the group that's equal to gravity? How many 8s make the group that's equal to 3/4? 6/8, right? And I only have 5 of those. How many do I need? 6. So Ramona's close, but she's a little off. What I really have is one whole group of 3/4, and that's 1, right? Because it's one whole group. But the leftover section is not 3/8. It should be 5/6. Because she needs 6 to make another group. She doesn't have 6. She only has 5. This is a really weird idea. Like, the process behind dividing rational numbers is really weird. So hear me when I tell you, this is hard. This is not an easy skill. I do not want you sitting here thinking like, oh, I don't know this yet, I'm so dumb. No, this is a hard skill. Okay? So now that we're good that this is a hard skill and that Ramona was wrong, I'm happy to answer more questions about this. Let's see what else. Madison used dividing 6. Which makes sense. Because, I mean, read what she said. Since 1 3/8 is the same as 11/8, and 3/4 is the same as 6/8, she's looking for groups of 6, right? So, like, on the number line, if we say 1, 2, 3, 4, 5, 6, that makes a whole group, right? So that's 1, group it together. Then I start counting in 1, 2, 3, 4, and I only have 5 out of the 6 that I need. So it's all looking at the size of chunks that we're evaluating. Now, I'm not sure exactly how to pronounce his name. Hoi? Sure, hi. So, hi, yeah, right, Guy, hi. So, hi actually does it the most efficient way you can. But to show this, I kind of want to pull up like a blank sheet up here. So I'm going to swap screens real fast. Oh, by the way, ironically, I was showing that slackline video to my other classes. My buddy texted me, my buddy that I rock climb with, Randy. I'll talk more about Randy this year because he works for architects. So I use him in some different problems. But he texted me. He was like, hey, do you want to go down to Audubon tonight? Which there's rock climbing and slacklining down at Audubon. So I thought that was kind of coincidental. 1 3/8 is really 11/8. Are we all comfortable on how we get there?
Yeah.
In my brain, I call it the triangle method, although it's not really a triangle. You multiply your 1 to your 8, then you add it up to your 3. So they all kind of like interact, but we're like missing a leg of the triangle. But I just, in my brain, I call it the triangle method. So we have 11 eighths, right? I just wanted to write a little fancier with the pen. So we're going to take that and split it into groups of, what's the division? I scrolled too far on the screen. Y'all are not helping me. 3/4? Okay, much appreciated.
But you still look anyway.
But that's not good, right? Because not common denominators. Don't have to have common denominators, but it would make more sense if I did. So if I make 3/4 common denominator, it's 6/8. Do we agree? I have not actually changed the problem. I've changed the numbers, but I haven't changed the problem. So then, and Ramona kind of did this, Madison did this, but she didn't show it. I can make my whole groups, right? A group will have 6 of the 8s. So imagine that this is like cookies or like something tangible. Every group is 6. So I take away 6 from what I have. I get a whole group. How many do I have left? 5. But that's the problem. That's where this gets really weird. It's not 1 and 5/8. It's 1 and how much of another group do I have? Another group is 6. I have 5. That's how we get to 1 and 5/6. But Hi doesn't like that work because it's really complicated. And Hi says, well, I know that division actually doesn't exist. Right? Division isn't actually a thing. Give me your eyes for a second. I'm not joking. I'm not like saying weird things. Division doesn't exist. Division's a word that we made up. Right? I like the question. So what does? Multiplication exists. Addition exists. Subtraction's a word we made up. Division's a word now every word is a word we made up if you want to argue. But division is multiplication flipped over. Right? If you say 8 divided by 2, what you're really saying is 8 times a half. Right? How many halves can I make with 8? Yeah. Yeah. Thank you. So what we do here, what Hi did, was he kept the first one and changed division to multiplication. But I can't just make division multiplication. I have to then flip the final, like the second fraction. So Hi does this. He says 11/8 times 8/6. Now, here, this just works out really well since I had common denominators up here. An 8 on bottom and an 8 on top will cancel each other out. Because if I don't, well, sorry, they will reduce out to 1. I don't want you guys to think they turn into 0. They reduce to 1. Because if I write this out, it's 88 over, what's 8 times 6? 48. And then I can reduce this down, and it becomes 11/6. Yeah, but KCF, kind of like KFC, but either way. Questions? That was a weird concept, weird problem, and like honestly, if you guys worked through the lesson and didn't like flip out, that means something really good about your brain being able to do the struggle, right? The struggle is beneficial. The struggle is when you learn. Any other questions from yesterday? That awkward time is a teacher strategy called wait time. No, like not many people have the confidence to immediately raise their hand and like or speak up. Like if you're in a meeting and you're asking for people to like volunteer or participate, you like need to wait a long time, almost enough to make it uncomfortable. And then somebody might actually like, fine, I'll say what I like. Yeah, Quinn?
What is love?
What is love? Baby, don't hurt me. No, okay, I don't know. Love is also probably made up. No, we were just talking about like all these made up words. Like, I mean, love's another made up word, but if you're asking like what it is, yeah, you're good. You don't have to ask me. All right, 3, 3, 2. Now we're gonna keep trying to conceptualize what we're doing and make more sense of this. So please ask questions when stuff doesn't make sense. Notice the no calculator symbol. So if you have it out, put it away. All right, so today we're going to review and practice working with decimals. While you might usually use a calculator, it's important that we know how not to use the calculator, right? So this way when we encounter it, and we might have, like on the state test, there is an entire section where you cannot use the calculator. So we want you to be comfortable with this. So if you have a calculator, you can use it to check answers, that's it. Mr. Garcia is working in the shop. Now, I often am working in the shop, and actually when we got nervous about the murals tomorrow, I was thinking about making big, like, wood chalkboards. You can use chalkboard paint, but I think we're good on weather. So let's say Mr. Garcia is working on a school project. He needs to cut short pieces out of a 16-foot long board, which is one of the longest lengths that you can get at Home Depot. The pieces he needs to cut for spacers are 9 inches long. So, with your group, figure out how many 9-inch spacers could Mr. Garcia cut. I'll give you a couple minutes. What do you mean, do these fractions exist? Is this what we're doing on our lesson right now? Did you look ahead on your homework and that's why you're asking me, or look ahead in the lesson? So to answer your question, yes, they exist, but I'd like you to be on top of this right now. So think about it physically. If we don't, so like what answer are you giving? Okay, so if it's 21 and a decimal, can I make that 22nd piece? So in the real world, would the answer be 21 or 22? If you ever need help conceptualizing stuff with fractions, you may use these. Just please make sure they all get back in the right spots. Right? Yeah, you can move on to the next one. I'm about to pull us back together. Let's use cards. Caitlin, is what I wrote up here accurate? We don't have to. What do we think? No. Why? It's kind of okay, but I can't do this math. Why? You can always pass. Did I have? Was your hand up? Yeah. Why can't I do this?
Because it's feet and inches, you need a common.
Now be careful. It's not common denominator. We need a common unit, right? We need matching units. So before I can start this problem, I actually need to convert feet into inches. How do we do that? Times 12. So if I do 16 times 12, what do we get? 192 inches. Now, a lot of times, like shop type people, carpenters and things like that, those conversions are really fast for them because they're used to, like, I want to just work with everything in inches. Even if you're working with long measurements, you'd rather just work in inches. It's like when I'm measuring like a room to install a ceiling light, it'll be like, okay, the room's 184 inches wide, so that you can find the middle, because that's a lot easier than saying, oh, the room is 7 feet 8 inches. Like, that's confusing. Don't break up units, just use inches. And then we can say divided by 9 inches. Right now, there's a number close to 192 that would be a boatload easier to deal with when I don't have a calculator, and I don't want to long divide because I'm like allergic to long division. I'm not. Well, I just don't like it. You know, I break out in hives. What number close to 192 could really easily divide by 9?
180.
Ooh, don't even make it that hard. Just do 180. So think about your measurement as 180 and 12, right? Because that's 192. What's 18 divided by 9? 2, but then put the 0 back on. 20. Can I get another piece out of this 12? Yes, I get 21, but then how many inches did I have left over? Out of how many inches did I want? So it's not 21 and 3/12 or 21 and I wanted groups of 9 inches. I have 3 left. Now, in reality, and I love that we were having this conversation at the back table. If I have this number, that I'm not going to make a partial. Right? So how many can I actually make? Is it 21 or 22? 21, right? Because I don't have enough lumber. Even if this was like 21.6 or 21.7 or 0.8, we can't round up because we're talking about real math, right? How many boards can I get? I don't round that. Well, I do, but I round it down. Because in reality, I can't round up. I can't all of a sudden glue some sawdust to the end of it and like make a, that doesn't work. So in reality, we would say really 21. That's it. Does that make sense? It's amazing, but we live in the real world and we can work with real numbers to do real math. It's pretty amazing. We can do real stuff. So, same idea, except now Sloan is a fraction wizard and decided to convert Mr. Garcia's measurements all into feet. So he realizes, I'll let you zoom in on this a little bit. Sloan realizes that, and I'm going to scroll up a tiny bit. 9 inches is 3/4 of a foot. Right? 9 out of 12 compared to the foot is 3/4. So that 16 over 3/4 also has shared units. So write on your paper 16 divided by 3/4. Now I'm going to break my rule. In this case, I would advise using the diagonal fraction mark because this is what we call a complex fraction. Because there's a fraction in a fraction, right? This is not right. It's not appropriate. It's like when you say the bad word instead of like one that you could have said instead. This is not appropriate. It works. It is what it is, but we don't write numbers like that. That's not good. So I want you to talk with your group for a minute and see how could I fix this? How can I get this to turn into a fraction that's actually appropriate? I want to essentially get rid of this being a fraction. So what could I do? Go for it. I want to get rid of the fact that that's a fraction. Who is this? Is this yours? Whoever has G9. Whoa, we do not say shut up in here.
Sorry.
Then people will die. You shut your whole face. You should jump inside my brain. It's pretty crazy inside of there. Wow. Sorry, this class is going really fast. Peyton.
Divided by.
Actually, anybody.
Okay.
I won't even use. So my question is going to be, why is the denominator a fraction? So I mean, if you want to answer it, you can. Otherwise, I'll just take hands. Why is the denominator a fraction? What makes it a fraction?
It's out of a hole. It's not one hole.
Okay. Yeah, it's less than a whole. It's out of a whole. So I just had 16 over 3. Would that be okay? Like, if I could, or, well, if I just had like a number over 3, right? So forget about like if I'm changing things or not. Like, so the problem is I have a number over a number that's being divided by another number. So the reason, you want to take another guess? The real reason a fraction is a fraction, and we were having this conversation in Math 7, because Ava was getting help from her dad, and her dad was like, oh, fraction, just divide that. Yeah. So a fraction is division, and division can be written as a fraction. The only reason that denominator is a fraction is because there's division happening. How do we undo division? So stick with me here for a moment. What if in the denominator I multiply by 4, but I can put it as 4 over 1, because then I could actually get 12 over 4, which really would just be 3. But if I do that to the bottom, I also have to do it to the top. Which really, what we're doing up there is just 4 over 4, like multiplying by it. And that, except this is ugly, is your giant 1. Yeah, I'm at a bad angle. So, what's 16 times 4? 64? What number close to 64 can I divide real easy by 3? Anybody out there? 60, right? What's 60 divided by 3? 20. Can I get another 1? Oh, wait. Same answer. There are 21 and a third. I mean, if we're going to be technical, there's a third of a piece left over. You with me? Because I don't see a lot of writing happening.
Don't eat my pizza.
This is one of the easiest ways that I can solve a fraction. But wait. Maybe I don't want to tell you guys that yet. Spill the rest of the tea.
Yeah. It's like TUC gossip. You know, math gossip. It's like spilling the beans. Only it's
So the reason I was debating whether I tell you or not is because the shortcut doesn't work as well here. But sure, I'll try to get some brain on my floor.
Brains on your
Yeah, like when I blow your mind. Get it? If I blow your mind, there's brain on the floor. So we said if we multiply by 4 down here, it gets rid of the division by 4. But what if I want to get rid of the entire, like, I don't want a fraction in the end, right? I want an answer, and like not a fraction, I just want an answer. Connor? If I do times 4 over 3, the 4 cancels the 4. The 3 cancels the 3, and this becomes 1. So if up here we multiply by 4/3, now here's why this doesn't work extremely well. If 16 could reduce out with the 3, this would be perfect. But it doesn't, so what we get in the numerator is still 64 over 3. And so we get the same thing we had, but we just get there a different manner. So in other problems, this technique works really well, because sometimes it all reduces out and just gets you your answer in one step. And you don't even have to think about the denominator, because if you know you multiply by a reciprocal, you know it becomes 1. Yes. Okay? Like tonight's or last night's? Do you have a header on it? Number what?
No, it's usually.
It was for multiplied division subtraction addition of mysteries.
What number though? What problem number?
386.
86. That's a couple days back. So, like A. Savannah, are you talking about A? Multiplication. But so you got to do A before B makes sense, really. Multiplication of fractions is easier. Straight through, straight through. So what's 5 times 7? 35. What's 7 times 5? Oh,
Wait, no,
35.
it's not that one.
Okay.
Sorry, it's 384 where it talks about the reciprocals.
Did you read the math notes box?
Yeah, I didn't understand.
Multiplicative inverses and reciprocals. There's a very minor difference. Well, not very minor. So there's additive inverses and multiplicative inverses. Inverse means, like, essentially does the opposite, right? The inverse of you is kind of like the opposite. So 8/5 compared to 5/8, like when I multiply them, I get 40 over 40, which reduces out to 1. Even if I start with a mixed number, like 3 1/4, which turns into 13/4, I then flip it, and when I multiply by that, I get 1. So one of the biggest ways that we can remember reciprocal is, and this is kind of lame, but refliprocal. When you see reciprocal, you should think refliprocal. Hey, Quinn. It's normally elementary school. I have to tell kids if it's not yours, don't touch it. Dudes, what is going on back there? Okay.
There's a fly.
So flies see in like 60 different directions at the same time. It's extremely hard to kill a fly. Okay, so just like let it. Man, this is probably gonna end up being a 2-day lesson. So remember that if you see long division, what's on the inside is your numerator, right? Inside numerator. So if we look at this problem, that's actually 16 divided by 0.5. So go ahead and drop that on your paper. This is number 100. I know I'm writing the space for 101, but this is problem 100. Now, if somebody gave you this long division, I bet you'd have to think twice or 3 times, or who knows how many times you have to think, but to figure out where the decimal should go. Because if you carry it right up here, well, that's like if this was just a whole number, which it's not. And that's not where the decimal goes. What do I need to do to this to make it a fraction that is appropriate? I can't say proper because it's for sure going to be improper. But how do I make it an appropriate fraction? Quinn?
Times both sides by 10.
We can times the top and the bottom by 10. Now, there's actually multiple ways, but I like that you just said that. So, by times 10, that moves this decimal point. I get 160 over 5. Can anyone see another way that we could get this in an appropriate fashion? Connor?
16 over 5 turns to 16 and a half, and times it by 2 over 1. 2 over 1 fraction.
Yeah, so Connor says turn this into 16 over a half, right? 0.5 is a half, and then times 2. Because times 2 on bottom turns this into a 1, I get 32 over 1. Oh, wait, there's my answer. So, multiplication by the reciprocal can zip us right to the answer. Can you please make sure we have a couple versions of this written down on our papers? I'll give you a minute. Because on your homework, you're going to need to utilize these skills. This stool has broken. I'm slowly going down. Seriously, every time I shift my butt, it like drops a little bit. sugar we're going down?
Sure.
Oh, so I'll move the thing up to there.
You can do it. You took a picture.
I think people see.
So, to get to a hard one, because we don't have a lot of time left, let's look at B in 101. Let's set up 1.5 over now 0.25. Go ahead and write that, but then change this to a fraction over a fraction. Challenge you, change both of them into fractions.
Challenge accepted.
You accept the mission? Good, because it's going to self-destruct in like 30 seconds.
Yep.
What is 1/2? Or sorry, not 1/2. 1 and a half as a fraction. Anyone? 3 over 2, right? Not mixed number, just a fraction. 0.25, 1/4. What do I need to multiply by to get my denominator to not be a fraction? Connor?
4 over 1.
Yeah, times 4 over 1. So this becomes 12 over 2 over 1. Yeah, what's so 12 over 2 is 6. I have to give you a handwritten invitation to take notes with us. Are you just tired today? Did you stay up late playing video games? Just be honest. I was going to ask you what's your video game of choice. You're not like in trouble. I can just tell you're tired. Rainbow Six. Tom Clancy. He knows how to write them. Right? Isn't that a Clancy video game? Because it's based off a book.
It is.
We got like 2 or 3 minutes. See how many of these you can bust out.
I'm going to bust out. I'm going to combust.
2 and a half. Easy fraction for that. How many halves would make up 2 and a half? Ooh, careful. 5 halves.
Good morning. At the class change, could I please see Destiny Marshall and Ava Matheny in the office? Destiny Marshall and Ava
Man,
Matheny.
both of those guys are my advisors.
Thank you.
What did they do? No, they probably just have messages from home. A lot of times if you get called to the office, it's just like your parents called and they took a message and like the office get no message. Which is nice that they're now calling them for at class change, because it's like a lot of you guys go to your lockers anyways. So like just pop into the office. 15 doesn't need to be rewritten as a fraction, but I will make my life easier. Like I said, my goal is to make your life easier. I'll make my life easier if I do, because what do I want to multiply on the bottom by? Do you know, Mallory? You got your hand up on the last one. By 2/5. Now, if the top is already a fraction, that multiplication's easier. Becomes 30 over 5, or I could have actually recognized that this cross reduces if they both are divided by 5. Now, if you're not comfortable cross reducing, it's okay. We'll get better at this through the year. But we cross reduce by dividing diagonal objects by the same thing. If I divide by 5 and divide by 5, I would get 3 times 2, which is 6. You get to the same answer no matter what way you take, like a lot of right ways to get to Florida, but cross-reducing is really convenient, and there's a poster of it. No, that's cross-multiplying, don't trust that. Maybe I don't have the cross-reducing poster up. Sorry. I have way too many posters, so sometimes I rotate through posters. I think I'm going to move those because they keep falling from above the lamp to above the doorway. So if you guys need to come and like pop into my room and check some of those shapes or formulas, I might put them up there. Yeah. So the flipping fractions, the whole turning division into multiplication that we did like a few minutes ago, that's on the yellow poster. If you want to remind it. Well, one of your classmates, very in tune with the world, said, shouldn't these numbers technically be like upside down? Yeah. I mean, if you actually flipped yourself upside down, the numbers would be upside down, but don't worry about that. All right, that's all the time I got. We're gonna have to pick up this lesson on Monday. We don't have class tomorrow. Go ahead and try to do your homework. We have Outsiders Day tomorrow. Yeah, Outsiders Day. Have a great day, guys.
I have a lot of clothes, but it's already about them.